Hey there, it's Shannon Matchick-Myers, and today we'll be looking at a question posed by a student. This is a homogeneous differential equation, and so we're going to use an appropriate substitution to solve it. So let's get this in the right format. We'll have y minus x times dx equals to y plus x times dy. Now we need to get the dy on the other side, so we'll have y minus x dx, and then I'm going to bring the negative inside because there's a positive in the formula for the differential form. All right, so m, of course, is y minus x. And then n is going to be equal to negative quantity y plus x. So if we let y equal to ux, because that's typically the one we try first, we would get dy using differentials in the product rule is going to be u dx plus x du. Okay, so now let's plug it all back in. So y is ux, and then we still have minus x dx, and then I'll just keep that minus out of here, and we'll have ux plus x, and then when I plug in dy, I'll have the quantity u dx plus x du equals 0. So dy was all of this right here, and y was ux. So now we will have x times u minus 1 dx minus, so I need to, distribute through, so u times x times u dx gives me u squared x dx, and then u times x times positive x du, so I did this one and this one, and there's a negative on the outside, so I'll have minus u x squared du. Doing the inside, we will have minus u times x dx, and another minus from that outside negative gives us x squared du, all equal to 0. So let's see if any of this will zero out. I'll just bring it back in, sorry. Ux dx minus x dx minus u squared x dx minus ux squared du minus ux dx minus x squared du is 0. Now the ux dx's zero out, so that's nice. And let's see, we want to get the dx's together. So we will have negative x dx minus u squared x dx minus ux squared du minus x squared du. So I'll factor out a negative x on the left from the first two terms, and then we'll have a 1 plus u squared, and then times dx. And if I factor out a negative x squared on the left of the second term, I will be left with a u minus 1 and then a du. All of these are equal to 0. Dividing through by x squared, I'll say by negative x squared times quantity So this is equivalent. I just want to get rid of all these negatives. Multiply by negative 1 on both sides, and we'll get x times 1 plus u squared dx plus x squared times u minus 1 du equals 0. So these are now separable. So if you divide through by x squared times 1 plus u squared and assuming x and u are non-zero, and they are, because y is equal to u times x, and y plus x can't both be 0 because this dE would be undefined. So this will give us dx over x, which is what we wanted, plus u minus 1 over 1 plus u squared du is still equal to 0. So integrating, this would be natural log absolute x, that's the easier one. And then if we take a look at the integral of u minus 1 over 1 plus u squared du, we can rewrite that as the integral of u du over 1 plus u squared minus the integral of 1 over 1 plus u squared du, adjusting by a factor of 2 and recognizing over here it's an arctangent setup and a is 1 and we just have u squared, so u will just be u. So this will be equal to natural 1/2 natural log absolute 1 plus u squared minus 1 over a is 1 arc tangent of u over a, which would be just u. I'll leave out the constant for now. We don't need the absolute value around 1 plus u squared because you're adding something positive. So we will have 1/2 natural log of quantity 1 plus, remember that if y was equal to ux, then u has to be y over x. So we'll have y over x, the quantity squared in that natural log, minus arctangent at y over x, which will be 1/2 times natural log of x squared plus y squared over x squared minus arctangent at y over x. So we'll have, so coming back and plugging in what we just found, we will have plus 1/2 natural log of x squared plus y squared over x squared minus arctangent at y over x plus c equals 0. So let's just multiply everything by 2 and get that c on the other side. So this is going to give us 2 natural log at absolute x plus natural log at x squared plus y squared over x squared minus arctangent at y over x equals c1. So we multiplied c by 2 to get 2c, then subtracted it to the other side, so you'd have negative 2c, which is another constant. So rewriting the first one is natural log of x squared, no need for the absolute value. And then we can bring it together now. So we'd have x squared times x squared plus y squared over x squared, all in this natural log. And then we have, a 2 times arctangent at y over x, multiplying everything by 2. And then we would have RC1. The x squareds divide out, and we're left with the natural log, quantity x squared plus y squared, minus 2 times arctangent at y over x equals c1. There you go. Hope this helps. If you like what I'm doing, Please hit the like button and subscribe. I hope you have a wonderful morning, afternoon, or evening whenever you're watching this show. Bye.